So let's take a look at this. We're going to name alkanes. So alkanes are single bonded carbon atoms. I threw an example out here. A couple of things is that these things work in chains. So for all these compounds, when you're naming them, you got to number the longest chain. In this case, 1. So each carbon has a number associated with it. So you number the longest chain. We'll go through some examples in which it becomes a little bit more complicated. We name how many carbons there are in the chain. So in this case, there's 5 carbons. So that's going to be pent. So pent means 5 now for organic. And then since it's single bonds, these are going to all end in A and E. So A and E. So we have pentane. Now, a couple things about this way. This is what they call the condensed formula. More often, though, you're going to see something called a line angle or skeletal formula for a lot of these organic compounds. You have to get used to both. So let's take a look at this. I'm going to redraw it, so it looks like a skeleton here. So this right here is equivalent to this. Let's go ahead and count these up just to make sure. So this is carbon number 1. This is going to be carbon number 2. So same thing as the one above. Each one of these little vertexes, that's a carbon atom. Notice, though, that we didn't put any hydrogens on there. So for these line angle formulas, most often you don't put hydrogens on there, though you can. Though sometimes you can put hydrogens on there, but in general, we don't. Let's go ahead and let's do a little bit more complicated one. One thing I do want to mention, let's go back to this line formula one here. So when you're looking at these right here, I brought a little model for this. So I brought this model. This kind of corresponds to this. 1, 2, 3, 4, 5. These things, since they're alkanes, they can twist around a lot. So they can twist around in all kinds of different directions. You always got to find the longest chain. So for instance now, so they can twist this way, that way, like this. I mean, whatever happens in solution, these things are always kind of moving around. So there's other ways to draw this skeletal figure right here, even the regular one too. We can draw it like this too. Let me try and draw it in contrast. So 1, 2, 3, 4. So even though that shape is different, there's still 5 in a row that's still going to be pentane. I could do it again. I can do something like this. So they're all the same. The only thing is I've changed the way these things are kind of twisted around. So you may want to build a model with this and say, okay, these things can twist all directions. Let me find the longest chain associated with it. Let's go ahead and throw some in there in which we have some substituents on the chain. So the ones I've drawn before, they're just carbon and hydrogens, but we can change it up. So let's go ahead and change it up here. Okay. So basically I've replaced a hydrogen with a chlorine. Couple of things with these things. Find the longest chain. This one's pretty easy. The longest chain is this right down the middle. That's simple enough. Now, when you're numbering these, you can number it from left to right. That's how we normally draw stuff. But you can also go from right to left, just as long as that chlorine is on the lowest number possible. So if I go this way, 1, 2. That chloro is on carbon number 5. Now, that's not going to be the lowest number. If I do it the other way, if I start from right to left now, call this carbon number 1. If I start from right to left, that chloro is on carbon number 2, which is actually the lowest number. So we got to number it from right to left. So you have to get used to it. That can start from left to right, right to left, whichever one has the lowest number with this. So my substitution is on chloro number 2. So I was going to say 2-chloro. That's where substituent chloro is. It's on carbon number 2. I still have 5 in the chain, so it's just 5 in there. So 2-chloropentane. So when you're doing this, find the one that has the lowest number, and you got to start numbering from that side with this. Let's go ahead and change this up even a bit more. Let's put a couple of substituents on there. Couple of things with this one. Again, you want to find the chain, whichever one starts, with the lowest number of the substituent. Now, in this case, if I start on this side, 1, 2, they both be 2. Even on this side, 1, 2. They both will be on carbon number 2, your first substituent. That's the one you put on there. Couple things about this one right here. We have to go alphabetical. So bromo occurs before chloro. So I'm going to start on the left-hand side. So bromo will be on carbon number 2, chloro will be on carbon number 5. And again, I have to do it this way because bromo comes before chloro alphabetically. To name this, so 2 bromo, 5 chloro, there's 6 in the chain in this case, hexane. So again, we go alphabetical, lowest number, etc. Let's go on which we have to look at the longest chain. So let's draw another one here. So this one right here, we have to be careful. We have to say, okay, what is the longest chain with this? There's several possibilities. I could do this. Usually the one down the middle is the one we think of, but it doesn't always have to be. So let's count how many I have in there. So 1, 2, 5, 6. Okay. I got 6 in the chain. Now that may or may not be the longest. There's another chain to that. We can actually have this right here. Let me use a different color here. Well, this right here, that could be a chain also. So let me go ahead and try to number this one. Let me get rid of these. Well, this chain has 8. Again, it's kind of snaking around there. So this one has more than the other one. Another possibility would be you can do 1, 2, 3, 4, 5, 6, 7. That would be 7. So again, I was looking at this one right here, so I can go to the left too. That would be 7, etc. But the one with the longest goes through this one right here, the one that kind of veers off towards the right. So let's go ahead and start for that. This is our longest chain right there. So our longest chain contains 8, so it's going to be octane. Sometimes you want to break this up into the chain and then the substituents. Substituents is on carbon number 5. In fact, let's go ahead and make sure. We might even, I think I made a mistake because this has to be on the lowest number here. So if I go 1, 2, 3, 4, 5, well, the substituent will be on carbon number 5. Let's try it this way right here. So 1, 2, 3, 4. So again, that's kind of a tricky one. I thought I was going to go this way because my mindset was set that way, but it can actually go this way. So this should actually be lower number. Again, it's all the same thing. 5, 6, 7, 8. So it's all going to be 8, but I got to go from left to right now because there's where the substituent is going to be. This right here is going to have 2 carbons. That's the ethyl group. So that's the ethyl group. It's on carbon number 4. I put that together. Try to sneak it here. It's 4-ethyl octane. So again, kind of get used to it. Snakes around here or there with this. Let's jump to another one. Let's look at some of these cyclic ones. These are always kind of important there. So we have a cyclic one. Again, it has this kind of a cube shape for this one right here. So carbon 1, 2, then 3, 4. A couple of things. When you number these, you can number it 1, 2, 3, 4, 1, 2, 3, 4. So again, we have the same rules. You want to number it. We have the lowest substituent on there. This right here, cyclobutane. It was butane. It was this 4, but now it's a cyclic. So it's okay. That's cyclobutane. Let me throw a substituent on there. Let me throw it right here. In fact, let's go ahead and make it a little bit more difficult. Let's do that. A few things on there. If there's just one substituent on the cyclic compound, that's always going to be carbon number 1. So this is carbon number 1. And then you can number the rest, whatever the case may be. We don't have to indicate that number because there's only one position. Everything else is equivalent. So I don't have to number that carbon as number 1. This right here is an important group to recognize. That's the isopropyl group. Couple things. This is bonded directly to the ring. So this is, got 1, 2, 3 carbons on there. It's bonded towards the middle carbon. And really, what I should number like this. So 1, 2, 3. 3 carbons in the chain. It's bonded off carbon number 2. We have to recognize this as the isopropyl group. Again, I number it oftentimes so I don't get confused. So it'd be isopropyl cyclobutane. And again, we don't have to write it's on carbon number 1 because there's only one substituent. It has to be on carbon number 1. Let's go ahead and add a second one to this. Let's do it here. Okay. So we have this one right here. Again, we got the same compound there. Have to recognize the substituents. This is isopropyl. It's carbon 1, 2. That's ethyl. Couple things. All these things are named alphabetically, like we've been talking about. Ethyl is before isopropyl. So now I have to number the substituents because I got more than one on there. So we have to say, okay, where this is at. I want the lowest number possible. I'm going to call this carbon number 1 because ethyl occurs alphabetically before isopropyl. I want to number it so everything's in the lowest number. So I'm going to go from 1, I'm going to go 2, 3, 4. If you number this another way, if I go 1, 2, 3, 4, that will put that isopropyl on carbon number 4, which you don't want. You want the lowest number possible. And so they kind of put it all together now. And again, I would say, okay, this is 1 ethyl, 2. When I'm numbering these, I kind of put it off to the side. It's okay, 1 ethyl, 2 isopropyl, and then I know it's cyclobutane. So I'll put it all together now. 1 ethyl, 2 isopropyl cyclobutane. So it's a bit longer. Let's do another one here. Let's look at this one. This is actually gasoline when you put in your car. Octane, but it's a different type of octane. Octane has more than one type, but they call isomers or forms associated with it. So let's find the longest chain. It's going to be this, so I don't have to Again, you can stop the video and kind of play with it, see which is the longest chain. But that's the longest chain. Now I got to decide which side to start on. If I start on this side, my first substituent was on carbon number 2. If I start on this side, my first substituent was on carbon number 2 also. But remember now, if I start from left to right, I have 2 substituents on there, so that breaks the tie. So the second one will be on carbon number 2. If I go from right to left, I think it'll be on carbon number 4. So we go ahead and start from left to right. So 1. So that's my main chain. So that's pentane. So a lot of times I'll break these out into pieces, then I put it all together at the end. So that's pentane. I got 2 substituents on carbon number 2. These are both methyls. I got 1 on number 4. That's a methyl. I can combine them all together. Now, when you're numbering these, you got to tell exactly where place is at. I got to write it for both of these methyls. So I'm going to write 2/2. So again, just don't write 2 for both of them. I'm going to write 2/2, which indicates to me, or to anybody who's reading it, that I have 2 of those. And then I'm going to say 4. I got 3 methyl groups. Well, try methyl. So try methyl propane with this. Let's go ahead and do another one here. Okay, let's take a look at this one right here. Cyclic compound. So that ring now, that's going to be cyclohexane. There's 6 in a row. I'm going to call from here. 1, 2, 3, 4, 5, 6. Again, we started with the bromo because that's alphabetically it's before the fluoro. So to put it all together now, so this is 1 bromo. That's 3 fluoro. It's cyclo. So I'm going to say 1 bromo. Cyclohexane. Let's just do one more with this one, and then we'll be done for the alkanes. This one's going to be kind of interesting. I think I wrote it here. So I think I got that one. Okay. I think I got that one. So a couple of things about this one. We always got to number it when we start the first substituent. So we find the main chain. Again, it's going to be from left to right. It's going to be this right here. We start on this side because in this case, the first substituent will be on carbon number 2. So always the first substituent with that. So 1. Okay. I got 6 of these, so that's going to be hexane. Couple things now. Let's name these substituents on there. Well, carbon number 2, I have a methyl. Also have it on carbon number 4, so 2,4-dimethyl. Carbon number 4, I have a bromo. So 4-bromo. Couple things with this. We put things alphabetically, not by numbers. And also when you're doing alphabetical, the di-tri we leave out. You go by the M in that case. But either way, bromo comes before methyl or dimethyl with this. So I got to put that first. Even though it's carbon number 4, I got to write that first. So it's going to be 4-bromo, 2,4-dimethyl. Oh, heck, I try to put it all together. It's all one word at the very end. So 2,4-dimethylhexane. So again, the 4 comes first now because that's bromo before that. So anyway, that concludes the alkanes. We'll go ahead and do another video on the alkenes.